A very good afternoon to all the beneficiaries for today's webinar. Brio International Nurturing Academy welcomes you all to today's one-day webinar on normality test using Spss software. Next slide, please. So before moving ahead, let us begin with a new beginning. Next slide. New mindset, new focus, new start, new intentions, new results. That is what we believe in. So be with the Bince Academy. Before moving ahead with today's session, let me walk you through the abouts of Brio International Nurturing Academy. Brio International Nurturing Academy is an online and offline educational and research academy based in India, which is registered under MSME, Government of India. Bince Academy offers wide range of educational topics for faculties and students, be it medical, nursing, or paramedical in their career development. With this, we move on to the next, and we are highly privileged and honored to have with us our eminent speaker, Dr. Bince, PhD nurse and a registered nurse. Talking about Sir's educational qualification, Sir has completed his BSc Nursing from Karnataka, MSc Nursing in Psychiatric Health Nursing from Madhya Pradesh. Sir has PG Diploma in Psychological Counseling and Guidance from Karnataka. Sir did his PG Diploma in Child Counseling and Guidance from Karnataka. Sir has passed Qatar Prometric exam from Supreme Council of Health Qatar. Sir has successfully completed PhD Nursing from Rajasthan. Talking about the teaching experience, overall, Sir has more than 10 years of teaching experience. Sir is presently working as an assistant professor at Hind College of Nursing, Uttar Pradesh, India. Sir is presently serving as a regional coordinator of Indian Society of Psychiatric Nurses, that is ISPN, in Uttar Pradesh. Sir is also an editorial member of esteemed journal of International Journal of Psychiatric Nursing. Talking about the memberships, Sir is a member of Trained Nurses Association of India, Indian Society of Psychiatric Nurses, that is ISPN. Sir is also a member of Nursing Research Society of India, that is NRSI. Sir is a member of World Non-Communicable Disease Federation. Sir holds a membership in Indian Public Health Association, that is IPHA, and that is a life membership. Sir is also a member of Nursing Teachers Association India. Sir is even a member of Scholars Academic and Scientific Society, that is SAS Society. Sir is an advanced trainer of the statistical package for the social sciences, that is SPSS trainer. Sir is also a trainer for R, that is EZR software, Minitab, Stata. Sir is a trainer at American Heart Association for Advanced Cardiovascular Life Support, that is ACLS, as well as Basic Life Support, that is BLS. Next slide, please. Talking about the research and statistics advanced courses of our speaker, Sir has completed 20 research articles which are published in international as well as national journals. Various scientific research papers and posters are presented at various national and international conferences. Sir has attended 1 week training course on biostatistical analysis, on SPSS and research paper writing in Institute of Cytology and Preventive Oncology, that is ICPO, Delhi, under Indian Council of Medical Research. Sir has attended workshop on basic biostatics and hands-on practice on medical data using SPSS software conducted by Institute of Liver and Biliary Sciences, Delhi. Sir has attended 4 weeks of interactive and practice-based training on research methodology and statistical package for the social sciences, that is SPSS, through the online workshop conducted by Inspire Analytic Limited, United Kingdom. Sir has successfully completed certificate course in statistical analysis, basic and advanced, using IBM SPSS software from Trans Trades, Bangalore. Sir has done NPTEL online certification course by Indian Council of Medical Research, National Institute of Epidemiology, on the topics of health research fundamentals and qualitative research methods. Sir has also done online certification course of health research fundamentals under ICMR. Sir has also completed online certification course of quality research methods under National Institute of Epidemiology. So, talking about our eminent speaker, I felt really honored and privileged. Before moving ahead and before I hand over the command of today's webinar to our speaker, I would like all the participants to please keep themselves mute. In between the class, if they come across with any doubt or if there's any query, kindly unmute yourself and then you can ask. And thereafter, please again keep yourself mute. That is a hearty request to all the participants. So I take this opportunity and privilege to hand over this mic to our eminent speaker for today's webinar. Sir, please come up and take the charge.
Thank you, Ms. Hitisha. Thank you very much, Bio International Nurturing Academy, for an opportunity to as a speaker in this section, and a very warm good afternoon to all the participants. Actually, our sections will be normality test using SPSS software. After completion of this course, we will understand the importance of checking normality of data. Okay, in this entire sections, we will learn histogram, QQ plots, box plot, Kolmogorov-Smirnov test, and Shapiro-Wilk test, and etc. all. Okay, before going to deal about this normalcy, we need to learn about certain terminologies in statistics. Then only we understand why, how to do normalcy and all the things. So that terminologies, it will take a half an hour. So what do you mean by statistics? Statistics is defined as the collection, analysis, and interpretation of data, especially numerical data. Hello, participants, am I audible? Hello?
Yes, sir. Yes, sir. Yes, sir.
Okay. Yes, sir. Thank you. Okay, statistics is, we all know about that. Statistics is the collection of analysis and interpretation of data. Okay, we can simply say term that as science of figures or digits or number. Okay, especially before going to statistics, we need to learn about certain terminologies. Data. What do you mean by data? Data is the actual piece of information that you collect through your study, especially in a researchers in their study, which all are the information they are collecting for the purpose of research study. That is data. Suppose if I want to check the height of adolescent girls, so which all are the information I collect during in that study, their age, their educational background, their weight, height, and everything else. That is my data. Especially data is two types. We already know about that: qualitative data and quantitative data. So what do you mean by qualitative data? Okay, qualitative data means information that can be measured. That is thing is qualitative data. Qualitative data means we can't measure it. That is qualitative data. Only the description of language are possible. Only based on the subjective description. That is qualitative data. It is also called categorical data. For example, appearance, beauty, color, stages of cancer, religion, gender. These all are the examples of qualitative data which can't be measured it. Okay, and there are two types of qualitative data are there. One is nominal data and one is ordinal data. Nominal data means we can say that a category is without any order. Okay, nominal data means it is a name categories that doesn't have any order. Order means in the sense we can't say that one is superior than another. For example, gender, and gender is male and female is there. So there is no any order is there. Suppose you can't say that male is superior to female, female is superior to male. Same like religion, sport. These all are the things are examples of categorical data without any order. That is nominal data. And another one is ordinal data. Ordinal data means categories that also category, but the thing is that categories without an order. For example, health status, we stand that poor health, average health, good health, stages of cancer, cancer 1, cancer 2, stage 1, stage 2, stage 3, wrong. Okay, these all are the examples, positive attitude, neutral attitude, negative attitude. So we can say that one particular category is superior than or inferior than another things. That is called ordinal data. Especially, for example, say that we can say that our rating scales, Likert scales, agree, strongly agree, disagree, like that. These all are things are the examples of ordinal data. These all are the things are coming under qualitative data or categorical data. Okay, that means we can't measure it. And another thing is quantitative data. Okay, quantitative data means information that can be measured. We can measure it by using certain kinds of scales, especially height, weight, temperature, everything we can measure it. This quantitative data is also two types. So sorry, it is quantitative. Typing error. A quantitative data is also two types: discrete data and continuous data. What is the difference between discrete data and continuous data? Means discrete data is the whole number. It is called discrete data. For example, I would say that number of children in your family, pulse rate, WBC count. Okay, that means we will get an exact number. Suppose if I ask how many members are in your family, then you will say either 4 or 5 or 6. You won't say that 1.5, 3.1. That is means we will get an exact number. That is called discrete data. But in case of continuous data, that we will get a fraction of values. That is called continuous data. For example, height, weight, systolic blood pressure, and all. For example, suppose if I ask what is your height, then you will say that 170 centimeter. 170 centimeter means there will be a millimeter will be there, nanometer will be there, picometer will be there. There are plenty of things are there after the point section. That's why it is continuous data. I hope you understood the difference between discrete data and continuous data. Suppose I would say that number of books in your shelf. So that will be a discrete data, because definitely you will say that 10, 11, 20, 100, any point. You won't say that 10.1, 10.2, something you won't say. That is, it is called a discrete data and a continuous data. Once again, I will tell you variables and data. We can two types. There is a qualitative data. It is also called a categorical data. And there is a quantitative data. It is called a scale variable. Especially in a SPSS term, we can say that all the quantitative data, it is a scale variable only. And qualitative data, we can say that a categorical data. In categorical data, there are two types of data. Nominal data is there, ordinal data is there. Nominal data, there is a no order. Ordinal data, there is an order. And in scale, quantitative data, there is a discrete data, counts and integers, and continuous data, measurements take any other point. For example, this is the example of nominal data. Okay, we can't say that a cat is better than dog. This is the ordinal data, rank. This is the discrete data, number of children. And this is the continuous data. Okay, your height or anything else. These all are about data. I hope you understood about the data. Okay, then we learned about the variables. Variables are the quantities, properties, characteristics of person, things, or the situation that can change or vary from person to person or situation to situation. That is about the variables. Especially in a statistical term, we need to learn about the two variables: height, weight, gender, knowledge level, religion. Everything will be a variable. But there are two types of variable you need to learn. First one is dependent variable. Dependent variable means a variable that may depend on other factor. So suppose, for example, exam scores may change, depends upon student's gender. exam scores may change, maybe due to the attendance percentage of the students. That is called dependent variable. But independent variable, which is not dependent on any other factors. For example, gender does not change depending on the exam score. Or we can say that another thing is that this is the examples of dependent variable and independent variable. So especially then we also know about, we need to learn about the population and the sample. The concept of population and sample is very important. Okay. Population means data obtained from a bigger group is called population, which is the large target group of investigation. A population is the entire collection of people, item, or events about which one want to make inferences. It is not always possible to examine every members of the entire population. Okay, sample means sample is a subset of population that is obtained, analyzed, and to make inference. To represent the population well, a sample should be randomly collected and adequately taken. So especially what is the difference between population and sample means, suppose if I want to assess the weight of the adolescent girls in India. So it is not possible to measure all the adolescent girls in India. So in that scenario, what we usually do, we select a representatives from the population. We randomly select 200 or 300, 400 samples. Then that sample only we do the measurement. That sample, that representatives, we can call it as a sample. And once we got the result, we generalize our result in the entire population. That is called a population. I hope you understood. Okay. Especially you can see that this is the symbols diagram representation of population and sample. Suppose as a researcher, what we need to do, we want to assess anything in the population. We want to assess anything in the population. For example, my question is that, my research question is that I want to assess the average weight of the adolescent girls. So what usually do, it is not possible to do each and every units of this population. So what usually I do, I randomly select a sample from this population. So then you get a sample. So after that, I get a certain kind of studies, statistics. Statistics means characteristics of the sample. I got a mean, standard deviation, everything we will get from the sample. Once we will use this statistical score and we can generalize our findings in our entire population, then you will get a parameter. That means population characteristics. That's all about the research. Now you understood about the population and the sample. Okay. So this is the population and this is the sample. Okay, this is one of the very simple example because we all cooked rice now. Because it is, suppose if you want to check whether our rice is cooked or not, at the time, what you have to do, you have to take a little amount of rice in our spoon, then you have to check. Then after that, you generalize that the entire plot of your rice, the entire the cooker, the rice is cooked or not. That means we can't check entire the rice, but the thing is that only the representative of this rice you have to select. Then after that, you generalize your findings, generalize your result. That's about the sample and the population. Before going to do about this, then we know about the classification of statistics. Okay, especially there are two broad categories of statistics. One is descriptive statistics and inferential statistics. We already knew about the sample, which only what is the descriptive statistics means nothing. Describe basic features of the sample. That is called descriptive statistics. So which, for example, we selected 200 samples from the population, 200 adolescent girls from population. Then which all are the result you got? Their religious status, their age status, or their height, weight, or any other kind of status. That's all about the descriptive statistics. For example, I would say the census of India. But what is the inferential statistics means? We use these descriptive statistics, and what we have to do, we have to make certain decisions on prediction in the population by using these descriptive statistics. That's about inferential statistics. Example, I would say that to test efficacy of new antihypertensive drugs. Otherwise, simple example, I would say that the efficacy of vaccines, COVID vaccines, especially Covishield, it is not possible to test every population in overall the world. But what the scientists and researchers is done means they selected a sample of 500 or 600 sample. Then what you have to, they started a trial. So once you got the result, that is the descriptive statistics. They got the result from their sample. 500 population. So after that, what you have to, researcher I do, the entire result is generalized in the population. That's why we are using this Covishield, Covaxin, like that, many vaccines. So this is the examples of inferential statistics. Okay. So especially descriptive statistics, there are 4 types of descriptive statistics are there. One is measures of central tendency, measures of position, measures of dispersion, and frequency and percentage. Okay, we will turn one by one. Okay, especially measures of central tendency means there is a one value which will represent the entire data. For example, we know the average value. For example, your intermediate percentage value, though you will say that the overall percentage 70% I got, that 70% is a one single value that represent your entire subject score, whether it is mathematics, whether it is history, science, language, and everything. So one single value will represent the entire value. Okay, especially measures of central tendency, we need to learn about the mean, median, and mode. Mean means nothing but the average value of the series. It is called the mean. Median means it is the middle value, and mode means highest repeated value, that is mode. Okay, suppose in an example you can see that the mean and median. So first of all, the mean means sum of the value divided by number of the value. So in first set, the mean will be, we have to sum all the value and then you have to divide by the number of the value, then you will get a one value, that is x bar is equal to 7. This 7 is representing all the values of the series. This 7 is representing 4, this 7 is representing 5, this 7 is representing 9, 10, everything. So that is called the mean. And next says in the same question will be find out the median. Median means when you have to arrange your data either ascending or descending order, then you have to select which is the middlest one, which is the 50th percentage of the data, middlest data. So you can say that this is the 7 is the middlest data, middle value is 7. So that is the median. So median, it is also called positional average. Based on the position only we calculated median. But one thing you have to keep in your mind, so this is another example. You can say that suppose I added 1000 in this case in the mean, so you can say that the mean is decreased. That means it is what it means. Then you can say that mean will be 148. But in the median will be 8 only. It's not that much drastical changes occur. So what I mean is that mean is calculated by using all the observation. But on the other time, median is not calculated by all the observation. Only ascending, or they are only the middle value. They are focusing the median. So that is the main reason median is not affected by extreme values. Mean is affected by extreme values. You understood, especially their outliers. We can say that if you have an extreme low values or high value, the median won't affect it. That's why the thing is that your data is not normally distributed. At the time you use median instead of mean. Okay, you can see because you can see that this 148 mean will represent 4. This 148 mean will represent 5. So this data is not a good representation. Yes or no? Am I audible now?
Yes, sir.
Yes,
Okay.
yes, sir.
In this scenario, this mean is not a good representative of this data. Is it good? There is a drastic changes in this data. Okay. Then we are not deal about the mode, because mode is we usually there are plenty of observation having more than one mode. There are plenty of observation having no mode. So mode is not usually using in a parametric test or any other test for comparing any groups. Only mean and median we are using. Okay. Okay, suppose one example. Have you seen this the serial number A student, B student, C student? A student scored 5 subject 50, 50, 50. B students got 5 subject 30, 40, 50, 60, 70. C students got 10, 100, 20, 50, and 70. So if you select one single value will represent the entire data, the mean will definitely will get to first series 50, the second series also 50, third series also 50. Then you wonder, this one value is a good option for a not only good option for representing the entire data. That's why what we are using the measures of dispersons also. Okay, only the measures of central tendency alone not represent the data effectively in such a scenario, because in these 3 students, if you ask the mean value, they will sell 50. Okay, in such a scenario, what we are usually do, suppose what till now what we learned, there are certain data, there are certain kind of data is there. the one single value, the central value you will get, that central value is a measures of central tendency, whether it is mean, median, or mode. But in a reality, we can't use only the central tendency value for representing the data. At the time, you need to assess how the other variable is deviating from the central area. Okay, that's why we are using measures of central tendency. Okay, measures of dispersion. Have you heard about the measures of dispersion? Measures of dispersion means how your value is deviating from your mean value, how your value is deviating from your mean value. That is called measures of dispersion. How your data is spread out. That is also very important. There are plenty of measures of dispersion: range, interquartile range, variance, and standard deviation. Okay, what you what you mean by range means the difference between minimum value and maximum value. Intraquartile range means IQR means we divided our data into, that means Q3 and Q1 and Q3. We divided our entire data into 4 parts. In that is called intraquartile range. Or variance means nothing, the average deviation of values from the mean value. And standard deviation means we will get a standard positive square root of the average deviation of value from the mean, that is standard deviation. For example, I would say that, okay, you can see that this is the standard deviation. Find out the mean and standard deviation. The first set of data, you can say that the mean will you get 7, the second and the standard deviation you will get 2.37. But in case of second set of data, you got the mean 148 and the standard deviation 378. That means the thing is that standard deviation means you can say that how the other value is deviating from the mean. X bar means mean. How the other value is deviating from the means, then you have to divide by number of the value. Then you will get a one value, that is standard deviation. Variance means nothing but the square of standard deviation, it is called the variance. So you can say that the both data, you can say the entire drastic changes in mean and standard deviation if I put one extreme value. So in a present scenario, the first data is a good, the mean and standard deviation we can use to represent the data. But second data, you can't use mean and standard deviation. This mean is not good enough and this standard deviation is not good enough to represent this data. For instead of using this data, we need to use median and intraquartile range. For that purpose, we are using normal probability distribution. Okay, another thing is measures of position. We will learn median, quartile, decile, and percentile. Median means we have to divide our entire set of data to equal part. Quartile means 4 equal part. Decile means 10 equal part. Percentile means 100 equal parts. Suppose we have a data is there. Okay, the median will be the central value. Okay, that means the right side is equal to left side. A quartile means we have to divide our entire data into 4 quarters. This is Q1, this is Q2. Q2 is nothing but the median only, and this is Q3. So especially this is median. Okay, suppose for example, I would say this is the example you need to understand. Suppose if this is the data, if you find out the Q1 and Q3, then you will understand the things. Okay, Q1 means 25% of the data, Q3 means 75% of the data. This Q2 means median, that means 50% of data. How to interpret this data? Q1 is 151. How to interpret this data? 25% of the students have height less than 157 centimeter, because this is less than 157 centimeter. Remaining 75% having height more than 157 centimeter. Can anyone interpret this Q3? Can anyone interpret this Q3? 169. Hello. Hello.
75% of students is having less than 169.
Okay.
Centimeter height, and 25% is having more than 169.
Oh, that is good. That is a perfect understanding. That means Q3 means 75% of students having height less than 169 centimeter, and remaining 25% having height more than 169 centimeter. This is about this is the use of intraquartile range, Q1, Q2, and Q3. Okay. Okay, then we are this is all about the introduction about the and the basic concept of this topic, today's topic. And today we are going to deal about the probability. What do you mean by probability? Probability means nothing, the occurrence of something, the chance of occurrence of something. Suppose if India and England match is going, so there will be a toss is there. The toss will tell which team will get the toss. Okay, that team can make a decision. So there is a probability to occur head is 50% and probability to occur tail is also 50%. Also in a reality we already we already play Ludo game. Okay, in Ludo game you can say that if we get a 6th digit then only we can enter the game. So what is the probability of getting 6? 1 by 6, yes or no? That is the probability of getting 6 means 1 by 6. That means there is a possible all 6 variant are there, but which number you want? 6. That means 1 by 6. The probability of ratio, number of favorable cases to the number of over cases. Especially probability means number of favorable cases divided by number of total cases. We can say as a P is equal to M divided by N. M means number of favorable cases and number of total cases. You got it now? So this is about the probability, especially what you mean by normal probability. It is very important. What do you mean by normal probability curve? Now you understood that it is very important in all the mathematical operation or statistical operation. Why we are using normal probability curve means, now we learned about the mean and standard deviation. Yes or no? Because in order to compare one group to another group, what our mean and standard deviation is a good representative or not, what we need to check it. If your mean and standard deviation is a good representative, then only you can use the mean and standard deviation. If mean and standard deviation is not a good representative in the data, then you can't use the mean and standard deviation for comparing the data. Instead of mean and standard deviation, you can use the median and interquartile range. You got my point now? So we want to check whether our data mean and standard deviation is a good enough to compare the data. Okay, suppose if your data is a good enough, then you can use a parameter test. If your data is not good enough, then you can't use a parameter test. You can use a paired non-parameter test instead of what it is parameter test. Okay, a normal curve is a bell-shaped curve which shows probability distribution of a continuous random variable. Especially you have to check your normality distribution in your quantitative data, whether it is discrete or continuous, that doesn't matter. Quantitative data only. Okay, and especially in normal probability curve, there are two things. It is mean 0 and standard deviation 1. Especially what you have to do, we get a standardized value. For example, percentage means, what do you mean by percentage? We have to convert our entire data into 100, 0 to 100. That is percentage. Same like what do you mean by pi diagram? Pi diagram means we have to convert our entire data into 360-degree angle. Same like in a normal probability curve, we need to convert our entire data into mean is 0 and standard deviation is 1. Okay, the parameters mean and standard median, and it is also called Gaussian distribution and bell curve and Z distribution. This is the other name of normal probability curve. Okay, you can see this is the normal probability curve. This is a bell-shaped curve. There is certain distributions is falling in right and left side. First, you can say that the mean value is the center, 0 value. Have you seen the mean value? The right side value is more values, the greater values than mean. That is the right side value. That is +1 standard deviation, +2 standard deviation, +3 standard deviation. Left side means less values comparing to the mean. That is -1 standard deviation, -2 standard deviation, and -3 standard deviation. The thing is that you have to check, because always it is not possible your data is normally distributed. But the thing is that nearly equal to normal distribution is an okay. But if violate your normal distribution, then you can't use mean and standard deviation. So in a distribution of this normal probability curve, you can say that the right side is equal to left side. There is a mirror copy of left side is right side. Okay, you can say that. And there is a certain percentage distribution is also there. That means -1 standard deviation to +1 standard deviation, there is a distance. That distance is 68% of the data. And -2 to +2, that distance will take 95% of the data. And -3 standard deviation to +3 standard deviation, that also 99% of the entire data. How to interpret this data, I will teach you. This is all about what it is called a normal probability curve. And also you can say the normal probability curve is going infinity. It won't touch the base. Okay, and the right side is equal to left side, that is symmetric. And also there are plenty of characteristics also that we will learn. Okay, especially you have to keep in your mind, normal probability curve means the area under the curve is 1. That means 100%. Okay, that means 50% right side and 50% left side. 50% right side towards the mean and 50% left side towards the mean. And also, you can say that the position, based on the position, you can say that this is if mu, this is the based on the position, you can see the normal probability curve. And based on the shape, you can see this, especially the standard deviation, you can use the standard deviation. If the standard deviation is more, then you can say that you will get a widened normal probability curve. If the standard deviation is small, then you will get a flat, narrow normal probability curve. Okay, especially I said that this is 0 point, this is first standard deviation and second standard deviation. Between first standard deviation and second standard deviation, it will be 68.26% of data is there. Between -2 and +2, there will be a 95% data are there. Between -3 and +3, there will be a 99% of data is distributed. Okay. Especially there are certain characteristics or properties you have to keep in your mind when doing the normality test. It should be a bell-shaped curve. Okay, it is a bell-shaped curve. Curve is a symmetrical. That means right side is equal to left side, and curve is a asymptotic. Asymptotic means it doesn't touch the base. It is going to the infinity. It is going to the right infinity and left infinity, minus infinity and plus infinity. And it is a unimodal distribution. Only one mode is there. That is called a unimodal distribution. If more than one mode is there, you can't say that your data is normally distributed. Another important thing is that all the measures of central tendency should be in equal or nearly equal. It is not feasible. It is not possible is equal, but nearly equal. Then only you can say that your normal probability curve is equal. That is, mean is equal to median is equal to mode. Then total curve under the total area under the curve is equal to unity. You can say the right side is equal to and left side it is equal. And another important features you have to keep in your mind, it is a two parameters, mean and standard deviation. The central value, it is high peaked value is your mean, and the less than mean value is goes in the left side, and more than mean value goes in the right side. On the basis on mean and standard deviation, we already say that is the distribution of the data that we learned last slide. This is the characteristics of the normal probability. It is a bell-shaped and symmetrical. You have to keep in these two, bell-shaped and symmetrical. Okay. Okay, suppose I will tell an example, then you will understand. Suppose in a normal probability curve. So what the thing is that as a researcher, suppose as a researcher, I have a curiosity that what will be the average systolic blood pressure in the population? As a, is it possible to measure entire the population, what it is, systolic blood pressure? No. So what I did randomly selected 200 population, then I checked the systolic blood pressure. So then what I have to check, my question, what is my curiosity? My curiosity that is their systolic blood pressure is in a population or in a sample, it will be a same or not. So then calculating this thing, I got a sample result. Mean is 120 and standard deviation is 5. Okay. So this is, so what you have to do, you have to convert this sample result in your normal probability curve. Then only you can generalize your findings in the population. What it is there, my 0, I just consider it as a 120. I put it 120. Then 120 minus 5, that is 1 standard deviation. That means 115. I put it my minus 1 standard deviation. Okay. And 120 plus 1 standard deviation. I have 120, 125. So I can tell that 68.25% of my samples and their systolic blood pressure lies between 115 to 125 mm of Hg. That is the interpretation of this. Okay, then the 2 standard deviation, you can say that 110, that means 120 minus 10, and here 130. Then you can say that 95% of all the populations, if you do this same research in any other population, then definitely you will get a 95% of your population sample will get the systolic blood pressure lies between 110 to 130 mm of Hg. And this is another thing, and 3 standard deviation, the negative side 105. That we can say that 95% of your data's blood pressure, systolic blood pressure lies between 105 and 135. This is all about normal probability curve and its interpretation. You got my point? So in order to generalize your findings in the population, that time you can use a normal probability curve. Okay. So for example, height, IQ also you can generalize your IQ also. Okay, this is the mean. Suppose mean is 100 and standard deviation is 50. Then you can say that 85, one standard deviation 85 to 115. That means you can say that 68% of population having average IQ level. Okay, then you can say that 70 to 130. That means you can say that 95% of population having IQ between 70 and 130. Like that, you can what it is, you can represent and you can interpret your data by using normal probability curve. Okay. Okay. And also I would say that it is not possible perfectly, you won't get all your continuous data is normally distributed. There may be some deviation from normalcy also there. In that case, there are two terms you need to name. One is skewness and one is kurtosis. Skewness means it is asymmetric or lack of symmetry. That is skewness. Suppose both the right end or left end is not equal. That is called skewness. For example, you can see this data. You can say that this is not a symmetry. Yes or no? Symmetry means there will be a bell shaped. Right side is equal to left side. Comparing to the peak point, central point, right side and left side should be equal. But in this scenario, you can say that right side is not equal to left side. Okay. So likewise, we can term it as a skewness, positive skewness and negative skewness. There will be a left tail is longer than the right tail is longer than the left tail. Then you can say that the positive skewness. And the left tail is longer than the right tail, then you can say it as a negatively skewed data. You can say that here you can say that the right tail is longer. Here you can say that the left tail is longer. That is positive skewness and negative skewness. The normal means the skewness will be 0. You won't get any skewness. Okay, that is normal distribution. Same like your data, this is based on the symmetry. Based on the height also you can. There will be issues also there. Kurtosis. Kurtosis means peakness or non-flatness. There are, you can see this thing. The central one is almost normal height mesokurtic, but this one you can see the leptokurtic, the narrow one. You can say that this is the narrow thing, and the platykurtic, that is, it is flat one. So that this is also violating your normality assumption. So you can say that a normal one, we can say that a mesokurtics, especially kurtosis value, you will get a 3, and the leptokurtosis means you will get a narrow value, the height will be more than 3, and platykurtic means the height will be less than 3. This is all about kurtosis and what it is. Leptokurtosis means the curve is more peaked, and mesokurtosis means similar to normal curve, and platykurtosis means less peaked. You can see that this also. This is more peaked, no? This is almost normal. Second one. This is, you can say, this is more flat. That is platykurtics. So that's about skewness and kurtosis. So how to check the normality? That is our main focus of interest in SPSS. How to check the normality? There are plenty of methods are there. First one is there is a visual method, graphical method. One is histogram, to draw a histogram. Then you have to check whether your data is, whether your diagram is normally distributed or not. Then you have to, there is a box plot. You have to check the box plot. Then you have to check whether the upper area and lower area is equal, symmetry or not. Like yes, you can check the from box plot, and QQ plot, that also you can check quantile plot. You can see all the value is nearly equal or nearly in their straight line. Then you can say that your data is normally distributed. That these all are things we will learn in our SPSS later practical section. And also how to check normality, statistical method. This is the most important thing, statistical method, because this visual method means it is subjective judgment. It will be feel a subjective judgment. What you mean subjective judgment means, if I feel that this histogram is bell shaped, then you won't feel that it is bell shaped. In such a scenario, it will create a problem in your judgment. So what usually do, usually we need an exact p value, significant value. We usually use statistical method, especially two types of statistical method is very important. One is Kolmogorov-Smirnov test, simple short form is KS test. If your sample size is more than 50, then you can use the KS test, Kolmogorov-Smirnov test, or Shapiro-Wilk test. That is, if sample size is less than 50, at the time you can use a Shapiro-Wilk test. How to make a decision? You check the p value, that means significant value. If p value is more than 0.05, that means your data follows normal distribution. If p value is less than 0.05, that means your data violate normal distribution. These all are the things we will learn. Okay, what will be our null hypothesis? Our null hypothesis will be data is normally distributed in the population. Or null hypothesis, data are normally distributed, and the research hypothesis say that data is not normally distributed. If your p value is less than 0.05 means what it indicates? If your p value is less than 0.05 means what it indicates? Data violate normal distribution. That means you reject your null hypothesis. If your p value is more than 0.05, then means you reject your null hypothesis. That means you saying that your data is normally distributed. You got my point? This is the two method we are going to learn. One is visual method and one is statistical method. Okay. So before going to things, I need to tell about the inferential statistics. What is the difference between inferential and descriptive statistics? Descriptive statistics means only the description about your sample, but inferential statistics means use that description and generalize your findings in the population. Especially we need to learn about the parametric test and non-parametric test. Parametric test is the test that makes assumption about the parameters and of the population from which data are drawn. Especially you have to keep in your mind that if your data fulfills normality assumption, then only you can use a parametric test. That means if your data is normally distributed, then only you can use a parametric test. Okay. It is also called a normal distribution statistical test. Okay. And assumption of parametric test means you have to select your sample randomly from your randomly, and also definitely it is a quantitative data. Your data should be continuous or discrete in nature. Then only you can check the parametric test. And also you have to check normally distributed. You have to check your data is normally distributed or not. And also you have to find homogeneity of variance, and your variance, that means measures of dispersion, should be same in all the groups. That also is very important. But moreover, you have to keep in your mind, this is the most important, you have to check your data is normally distributed or not. If your data normally distributed, then only you can use a parametric test like a t-test and all. If your data violate normality distribution, then you can't use parametric test. You can use instead of non-parametric test. Non-parametric test means if your data violate parametric assumption, then you can use a non-parametric test. That means it is also called a distribution free test. There is no such, only less assumptions are there. That is about parametric and non-parametric test. We already learned that what is mean and standard deviation. Certain scenario, mean and standard deviation is good enough to compare your result. In that scenario, definitely that scenario you can use a parametric test. In violate that scenario, then you can't use mean and standard deviation. Instead of mean and standard deviation, you can use a median and intraquartile rates. Likewise, all the parametric tests we can use mean and standard deviation, but non-parametric tests we can use median and standard deviation. How we need to check whether you can use mean and standard deviation? You just check normality test. If your data is normally distributed, then you can say that you can use a parametric test. Okay. In a hypothesis test, there are certain parametric and non-parametric tests are there. Paired t-test, Wilcoxon's iron rank test. If your data is fulfill your normality assumption, then only you can use a paired t-test. Otherwise, violate it, then you can use a Wilcoxon's iron rank test instead of paired t-test. Same like a repeated mesh ANOVA, we will one by one we will learn. And if your data violated that thing, it is Friedman ANOVA you have to use. And parametric test, independent t-test, the counterpart Mann-Whitney U-test. And ANOVA, the counterpart is Kruskal-Wallis test. Same like a Carl-Pearson test is a parametric test, and a Spearman rank test is a non-parametric test. Okay. Then we need to learn about the test of significance. Test of significance means which is the accurate test you have to apply in the given situation. That is the test of significance. That means test of significance required whether the difference or association or correlation two or more variable is due to chance or not, which all are the test of significance. First of all, you have to identify the data and variable. You have to identify whether it is quantitative or qualitative. You have to identify whether it is nominal, ordinal, or continuous data. Then you have to check the normality. Once, if your data is fulfilled your normality assumption, then only you can use the parametric test. Otherwise, you can use a non-parametric test. Then once after the formality, you can understand which test is appropriate. Once you take the test, you have to state the null hypothesis and research hypothesis. Then after that, you have to do the test. Then you will get a p-value and the test result. Based on that, you have to make a decision. That's about the parametric test and norm parametric test. That's now also you understood what is the importance of normality. In order to do all the mathematical operations, you have to do these things, checking all the especially your data will be quantitative in nature. At that time only you can use a normalcy test. Okay. Suppose first example, my objectives will be to check is there any significant difference in the average systolic blood pressure between two time point 1 and time point 2. Which test I will use? Systolic blood pressure. Which type of variable it is? Qualitative or quantitative? Hello?
Quantitative.
It is a
Quantitative, sir.
quantitative. It is a quantitative. Okay.
Quantitative.
So that means it is a quantitative data. So you have to check time point 1 and time point 2. That means a pre-test and post-test. That means paired situation. So in this case, there is a two option is there. One is parametric test. You can use a paired t-test. That means your systolic blood pressure time point 1 and time point 2. That means pre-test, post-test, your systolic blood pressure is normally distributed. Then you can use a parametric test, paired t-test. If any of the test time point 1 or time point, that means pre-test or post-test, any of the test is violating normality assumption, then you can't use a parametric test. You can use a non-parametric test, that is Wilcoxon signed rank test. Okay, so then we will go to the example. Actually, today I sent one Excel sheet to you. Have you got it?
Yes, sir. Yes, sir.
You downloaded
Yes,
also,
sir.
no? You downloaded also. You downloaded SPSS also, right?
Yes, sir.
Okay, here you can see the in Excel sheet, you can see the first is serial number, which is serial number, which type of data it is? Serial number, which type of data? Quantitative or qualitative? Hello?
Quantitative.
Okay, one thing you have to keep in your mind, this serial number is nominal data. It is a qualitative data only. Why? Because this is an identification purpose only we keep is this one. For example, your Aadhaar number, your IP number, your passport number, everything is only the purpose of your identification only. You can't say that my Aadhaar number is 7,000 something, it is started with 7,000 something, that is superior than your Aadhaar number. You can't say like that. It is a all the things you can use for identification purpose, that is only nominal criteria only. For example, the IP chart, IP number you got whenever you are going to hospital, you will get an IP chart, IP number. Okay, that IP number is a nominal data only. You can't say that one IP number is superior than another IP number. Like that, you can't say. That is, the serial number will be a nominal data. What will be gender? I coded gender. 2 is male and 1 is female. Which type of data it is a gender? Hello? Hello?
Qualitative data.
Especially it is a qualitative data. Okay, definitely it is a qualitative data. Just differentiate. Do you have any, is it's having any order or not? It's not, there is no any order, no? Male is superior than female, female is superior than male. We can't say like that. No? That is, it is a nominal data. So can you say the treatment? One means I put the treatment A, 2 means treatment B, 3 means treatment 3. This is also nominal data. Systolic blood pressure, which type of data? Continuous data, quantitative data. This all the other variables are quantitative data. HB, head circumstances, brain volume, maternal weight, maternal height. Everything is a what it is? Quantitative data. But in SPSS, you have to keep in your mind SPSS all the data, all the quantitative data. We can call it as a scale variable. Okay, so this is our data. First, I will tell you we have to import your data. How to import our data? So you have to open your okay, you open your SPSS. How you open? Hello? Hello, am I audible?
Yes, sir.
Yes, sir.
You open your SPSS. There will be a unified one data set one, then like that you will get. Have you opened it? Okay, then I will tell you we have to import our data. How to import data? Go to file. You can see in my screen, import data. There is an option Excel. Go to file, import data, Excel. Then you have to select where you downloaded that file. In my case, I got from this slide. So the Excel sheet which I sent, you have to import. Okay, you have to select that sheet. Then you have to press open. So then they will ask. Which sheet. I ask default it is sheet number 1. I won't do anything else. Sheet 1. Then you want to tick or untick any of the things. You have to press OK. Then my data is opened like that. Hello. Hello, you all are doing now?
Yes, sir.
Okay. You can see in my screen now.
Yes, sir.
Okay. You all did in this thing. You can see the data view. This is the data view. This is the entire data view. In here, you can see the variable view also. Okay. This is first variable is gender. Second variable is treatment. Okay. Then you go to variable view. Have you seen the variable view? Hello. Hello.
Yes, sir.
Okay. Then go to variable view. In variable view, first is serial number. Serial number, which type of data? In measure, you have to change it as a nominal because name category. So identification purpose only you are keeping name. Okay. Second one is your gender. Gender, it is also what, which type of data? That also nominal. Treatment group is also nominal data. Remaining all the variables you have to change it as a scale variable in a measurement view. Have you seen it? Hello? All are there, na? Hello?
Yes, sir.
Okay. Then what the thing is, serial number, gender, and treatment group, you have to convert it to nominal. Remaining all the variables you keep as a scale variable. Here you can say that in data view, you can say that the HB baseline, you can say that the plenty of 0, 0, 0. Plenty of decimals are there. We don't want these much decimals. So how to change it? Go to variable view. Here decimals you have to put 2. Instead of 15, you have to put 2. In decimals, you have to put 2. Instead of 15, you have to put 2. Then you can see the decimals only 2. After point, only 2 number is there. Have you got it? Hello?
Sir, again.
Okay,
Sir,
nothing.
again, please.
Nothing. You go to variable view. Variable view. Baseline, HB baseline is the decimal. It is 15. It is written 15, right? So what you have to do? 15 means after point you will get a 15 digits. We don't want a 15 digits. Only wanted 2 digits. So you have to reduce it. You have to keep it 2. You got it, ma'am?
Yes, sir.
Okay. Then one thing you have to keep in your mind that gender, there is a value. Have you seen the value? There is a value is there. Have you seen the value gender? Hello? Okay, in gender, you have to check that none. That means values. Then you put 1 means our female. Then you have to add it. 2 means your male. You have to add it. Then press OK. Have you done it? Hello? You are not responding. You are doing na, along with me. Hello?
Yes, we are going.
Okay. Then treatment groups also you have to do. You have to convert. That means you have to check values 1. You have to give treatment. Treatment A. You have to write treatment A, value 1. Then press add. Treatment 2. You have to press treatment B. Add. Treatment 3 means it's your treatments. Sorry. 2 means what it is? Your treatment B. What will be 3? 3 means your treatment Z. Then add.
Treatment C.
Add, then press OK. Have you done it? Once again, I will tell you, because in an SPSS window, qualitative data you have to code it. All the qualitative data you have to code it, because here gender and treatment group you have to code it. And these another variable, this continuous data, all the variable is considered as a scale variable only. You don't do any coding in scale variable. Only the gender. Have you seen the gender? Gender, what I did? 1 value 1 and I put male. Then I add value 2. I put a female. Like that I add and I press OK. Same like a treatment. You got my point? Hello? Hello, please. Hello, please unmute. Hello. Hello.
Yes.
Okay, you understood now? Please unmute. You have any? Once again, I will tell you, then you will understand what I did. If you are not understanding, I will tell you what I did, because I didn't get any. Okay, suppose gender, what I did, go to values. I need to code it because I coded 1 and 2. What I did, go to values, then values I put 1. 1 means my female. I add. Once you put a 1, then label female, then you have to press add, then 2, then you have to paste this male, then you have to again add. After adding 2 things successfully, then you have to press this OK. Okay, then the treatment group also, what you have to do? 1, that is treatment A, 2, treatment B, and 3, treatment C. You got my point? Then the data view, you can see the data view. Then you go to the data view, then you can say that it is automatically changed the gender and treatment, male and female, treatment A and treatment B. Okay. Hello.
Yes, yes.
Okay, okay.
Yes.
Hello, sir. Sir, in my file, it's not changing.
Okay.
I have all. Hello, sir. I have already allowed treatment and gender also, but in the way data view, it's not saying
Madam,
as.
there here you can see my screen. There is a one symbol, 1 and A. Have you seen it?
Sir, yes, it's
How to
same.
press that symbol? Then you will get a code value. Then you can say the code value.
Oh.
One press once again, then
Okay.
you will get a treatment and all. Oh, is it okay, ma'am?
Okay, sir. Yes.
Okay.
Yes, sir. Okay.
Okay.
Thank you, sir.
Then what will be our question? What will be our question?
Like parametric test.
Okay. Our question will be what it is. To check is there any significant difference in the average systolic blood pressure, time point 1 and time point 2. So first we need to check whether your data is normally distributed or not. So how to check that things I will teach you. Go to analyze. Have you seen the analyze? Go to analyze. You all are doing along with me now. Go to analyze. There is a descriptive statistics. There is an explore. Have you seen the explore window?
Yes.
Okay. Then what you have to do? You have to press that explore. Then there is a one short window. Now, what is your dependent variable? Both they, yes, systolic blood pressure is your dependent variable. Now you have to put
Yes.
systolic blood pressure 1 and systolic blood pressure 2. That means pre-test and post-test value. Only 1 and 2, systolic blood pressure 1 and systolic blood pressure 2, you have to put in your dependent list. How to do? I will tell you. You have to press systolic blood pressure 1. Then there is an arrow symbol. Have you seen it? You have to press it. Then you have to press systolic blood pressure 2. There also there is an arrow symbol. You have to press it. Okay, that is the dependent list. Because here factor list means we don't have any factor, only the time series. Okay, then what you have to do? Go to statistics. Nothing you have to do the statistics. You have to press continue. Then most important things, there is a plot option. Have you seen the plot option? Hello.
Yes, sir.
Okay.
Yes, sir.
Plot option, you have to press it. Then box plot, it is by default, it is selected factor level. In the descriptive, you have to deselect stem and leaf. You have to select a histogram. You have to deselect stem and leaf and select a histogram. Then normality plot with the test, you have to put a tick. Have you done it? Hello, have you done it?
Yes, yes.
Okay, nothing. Box plot the factor level together. Descriptive statistics, you have to put a histogram, and normalcy plot with the test, you have to test and then press continue. Then press continue and then press OK. Nothing you have to do. Then you have to press OK. You got my point now? Hello.
Yes, sir. Yes,
Okay.
sir.
Then you will get an output window.
Okay.
Have you got the output window?
Yes, sir, got it.
Are you able to see my output window? No, no.
No, sir, no. Sir.
Okay, okay, I will share it.
ए साउंड कमी करो.
Now, are you able to see my output now?
Yes, sir.
Yes, sir.
In output, you will get a first cross case processing summary. Here, you will get a systolic blood pressure 1. Hello, there is a sound noise. Can you please mute? Okay. In case processing summary, you will get the number, total sample size. In systolic blood pressure 105, diastolic blood pressure also 105. Okay. Then the percentage also nothing. The descriptive statistics, you will get a systolic blood pressure 1. That means pretest that means systolic blood pressure pretest, you will get a mean value, confidence interval, median, variance, standard deviation, minimum, maximum, range, and everything you will get. That doesn't matter. And the systolic blood pressure 2. That means your post-test value. You also get these. All are the values. Okay. This skewness and kurtosis. Skewness and kurtosis is nearly equal to 0. Equal or nearly equal to 0 means your data is normally distributed. That doesn't matter. You just what you have to check. First, you have to there is a test method, statistical method is there. One is Kolmorov-Smirnov test and a Shapiro test. Have you seen it? Hello? Hello?
Yes, sir. Feel it.
Yes,
Yes, sir.
sir.
Yes, sir.
One thing you have to keep only the significant value. SPSS is written significant. SIG, that means the P value. Okay. SPSS is written significant means P value. You have to check the P value. First things, KS test and Shapiro test. I said that if your sample size is more than 50, then you use the KS test. Otherwise, you use the Shapiro test. In this scenario, what is our sample size? Hello. In this scenario, what is our sample size?
105, sir.
105. That means it is more than 50 now. So which test you will apply?
Yes, sir.
Which test you will apply?
Kolmogorov.
Very good. Kolmogorov-Smirnov test. Short form is KS test. KS test, you only bother about the significant value, the P value. Have you seen the P value? Have you seen the P value?
Yes.
Okay. You only see the P value. You have to check your P value is more than 0.05. If your P value is, otherwise significant value is more than 0.05, that means your data normally distributed. If your value less than 0.05, that means your normality assumption is violated. That means violate normality assumption. So can anyone say that what is SPP1? That means pretest systolic blood pressure 1, whether it is normally distributed or not? Check, tell the P and make a decision. Hello? Is it more than 0.05 or less than 0.05? Hello, am I audible?
It's more than 0.0.
Okay, it's more than 0.05. Then you can say that both the first value and the second value is more than 0.05. Okay, that means both your systolic blood pressure 1 and systolic blood pressure 2 is normally distributed. That means you can use a parameter test. If any of the value is less than 0.05 or if any of the value is violating normality assumption, then you can't use a parameter test. Here you can use paired t-test in this scenario for comparing pre-test and post-test systolic blood pressure. You can use a paired t-test. How you use paired t-test? Because your pre-test and post-test systolic blood pressure is normally distributed. You got my point? Why we
Sir,
use
can you please repeat it once more?
Okay. Here, KS test and Shapiro test. If your sample size is more than 50, then you can use a KS test. Here, in our situation, our sample size is 105. Here itself, you said you got the sample size. Systolic blood pressure 105, systolic blood pressure 105. Then you can use a KS test. Systolic blood pressure KS test, significant value you can select. Significant value you can say 0.1155, like it's written now. Hello, 0.155, like it's written now, madam.
Yes, sir. Yes, sir.
That is more than 0.05, isn't it? That's why your data is normally distributed. Second value is 0.130. That also more than 0.05. Yes or no? So both value is more
Yes,
than 0.05. That means both value is normally distributed. If both value is normally distributed, then which test you can use? The paired t-test. If any of that value, systolic blood pressure 1 or systolic blood pressure 2, is violated normality assumption, then you can't use the parameter test. You can't use the paired t-test. Instead of using paired t-test, you can use the Wilcoxon sign rank test. You got my point now?
Yes, sir.
Okay, then you can see the histogram. Have you seen the histogram? You double click histogram, then there is a one new format will come. Otherwise, there is a symbol is there. Have you seen it? Show norma. Okay, you didn't share, no? 1 second. Now you can see one chart editor. Have you seen the chart editor? If you double click the histogram, you just see the
Yes.
screen.
Yes, sir.
Then there is an option. Have you seen this option? Have you seen this option? Show normal curve. You have to press that one and you have to close it. You have to press it and you have to close it. Then this also you have to minimize it. Then you can see there is a curve. In the output, you can see the curve. Have you seen the curve?
Sir, can you repeat once again?
You have to double click it.
Where?
Double click it. In that your histogram, you have to double click.
Okay. Okay.
Then there is a charted file. It open a charted file. Have you seen the chart editor?
Yeah, chart editor. Yes, yes.
Then here there is an option. Here nothing, only you will get a histogram. There is an option. Have you seen the option?
Yes, explode and collapse slides.
There is an option. You just see the window. Have you seen it? You are not seeing now. Once again.
Yeah, not seeing the histogram. Chart editor, it is there, that 1, 2, 3, third column, third row, right?
Not,
I think so. The third row is on the.
Not
Yeah.
third, 1, 2. Have you seen? Now you can see 1, 2, 3, 4, 5, 6, 7, 8th one. 8th one. Have you seen the 8th one? You have to press that thing and press close it. Then you will get. Okay. Anyway, that doesn't matter. That is only we will get a curve only. So this curve you can say
that is normal uniform exponential Poisson curve, right?
This is a normal curve. This is a frequency polygon. Okay. Then you can see
that. Yeah, I got it.
Okay. Then you will get a curve. Then based on the curve also you can judge whether your data is normally distributed. How you will judge? You need to check whether this data is bell shaped or not. Then you can say that it is almost bell shaped or not. This is the visual representation. In down, you can see the QQ plot, quantile plot. In quantile plot, we have to compare the observed value and expected value. Okay, then there will be a point value, 0.1, 0.2, 0.3. There are plenty of point values there. How you have to interpret this data? There is a straight line. If your all the value is equal or near to this straight line, then you can say that your data is normally distributed. You got my point? If all the data is equal or near to this straight line, because here you can say that almost all the data is touched, only 1 or 2, 3 data is don't touch, but it is also near to our straight line. That is QQ plot, quantile plot. You got it? These all are the visual representation. First one is what it is, histogram. Second one is QQ plot. You got my point? Hello?
Sir, in this histogram, and when we compare it with QQ plot, I think this QQ plot is much betterly representing the normalcy.
No, we can't say
Because
these visual. We want, as a statistician point of view, you can't rely on this visual representation, because this
Okay,
visual
sir.
representation is purely based on the subjective judgment. If
Okay,
I may
sir.
feel that this is normally distributed, suppose when you see this diagram, I feel that this is normally distribution. You may feel that this is not normally distributed. It is violating. It is not bell shaped.
Yes,
Like
sir.
that you can say. So that's why
Yes, sir. Yes, sir.
I prefer you only check the test only, statistical test, KS test or Shapiro test. This is only for this visual representation. You don't rely on visual representation. You got my point?
Yes, sir.
Okay, thank you. This is QQ plot. Third one, then you just rendered normal. This is ignore that one. Then there is a beautiful box plot. Have you seen the box plot?
Yes, sir.
In box plot also there are plenty of meaning is there. Box plot. Have you this dash? Have you seen this dash? The first one. This is the minimum value. The minimum value is this. It is denoted by the minimum value, and this is denoted by the maximum value. Have you seen it? Hello?
Yes, sir.
Okay. And the central value will be your median. That means 50% of your data. Central value will be your median. And this is your Q1 value. That means 25% value. This is your Q3 value. That means 75% of value. This is the meaning of box plot. Box plot means, once again, I will example. This box plot, every line has a meaning. This line is minimum value, and this line is maximum value, and the central line is your median. So, for example, I would say that my minimum systolic blood pressure is 110, and maximum systolic blood pressure is 130, and 120 is my median. Median means 50% of data, and 117, something related to 117, that is your Q1. Q1 means 25% of data, and Q3 will be this data. You got my point?
Yes, sir.
How to check the normality by seeing the box plot means you have to check, this is your median, na? The right side equal to left side, whether both right side and left side is symmetry or not. By seeing this thing, you can say that it is symmetry, but always by visual representation, you can't give a good judgment. So, but this scenario, while seeing this thing, you can say that the right side is equal to left side. It is a symmetrical. Then you can say that it is normally distributed. Okay, you got my point?
Clear, sir.
Same like a systolic blood pressure 2. That means systolic blood pressure. Now we learned about systolic blood pressure 1. Systolic blood pressure 2 also. You can see this one, histogram. Okay. You have to check whether it is a bell-shaped or not. Then QQ plot. Here also QQ plot. You can say that almost all the things are nearly equal to that line. Then you can say that your data is normally distributed. Trended normal QQ, you just ignore it. Then you have to check the box plot also. Box plot also you can check whether comparing to median, upper side and lower side is symmetrical or not, equal or not. You got my point?
Yes, sir.
Okay. What about others? Hello?
Yes, sir.
Okay.
Yes, sir.
So what was our question? So you tell which hello, some sound issue, can you please mute it? So what was our question? I want to check is the difference in SPP time point 1 and time point 2. So which test I need to use?
Parametric.
Very good. Parametric test, paired t-test. Why we used paired t-test? Because our data fulfills our normality assumption. Any of our data not violated normality assumption. Suppose our data violated normality distribution, then you can use the Wilcoxon sign rank test. You got my point now? Okay, second case. to check is there any significant difference in the average HB at 3 different time point. Okay, it is also a paired situation. More than 2 time point is there. In such a scenario, paired t-test, repeated mesh ANOVA you can use. Non-parametric test, Friedman ANOVA you can use. That means if your HB value 3 time point, all the value is normally distributed, then only you can use the paired repeated mesh ANOVA. Otherwise, you can use the Friedman ANOVA. Can we do the practice now? Hello? Hello? All of you?
Yes, sir.
Okay, we can do the practice.
Yes, sir. Yes, sir.
But because you can
Yes,
see
sir.
you can see the HB baseline, HB 1 month and HB 4 month. Have you seen it now? You check whether this data is normally distributed or not. How to check this data? Go to analyze, descriptive statistics, same option. Explore, go to analyze, descriptive statistics, explore, press it. Then by default it is selected SPP. You have to reset button. Have you seen the reset button? Okay, paste, reset. Then you have to reset it. Then it will come a starter window. Okay, then what will be the question? HB hemoglobin on 3 time. HB baseline you have to put in dependent variable. HB 1 month you have to put in dependent variable. HB 3 month you have to put in dependent variable. So that means you have to put HB baseline, HB 1 month and HB 4 month. Okay, then go to plot. Then go to plot. Instead of stem and leaves, you have to select histogram. And this is most important, normality plots with the test. Then press continue. Okay, then press OK. Then you will get an output. Have you got the output?
Yes, sir.
Okay, first things you have to check what is your sample size. Can anyone say what is your sample size?
105.
105, no?
Not five.
105. If your sample size is
105.
more than 50, then which test you can use? KS test or Shapiro test? Hello?
Case.
Case test.
KS test. Very good. Then you go to that test of normality. So KS test significant value you can say. So anyone interpret the data, HB baseline, whether it is normally distributed or violated normality assumption. Go to significant. Can anyone say the significant value? What is the significant value you got? 0.003.
0.003.
That is more than 0.05 or less than 0.05.
Less than.
That is less than 0.05 means your data violated normality assumption. Yes or no?
It is not probable.
That
Not
is
equally
not
distributed.
normally distributed. Second data HB 1 month. That also not a normally
Equally distributed.
HB 4 month.
Not normally distributed.
HB 4 month. HB 4 month.
It is normally distributed, sir.
It is normally distributed.
But since we actually, if you want to do parametric test, then definitely all these three should be normal distribution. But any of the one is violating normality assumption, then you can't use the parametric test.
Non-parametric
So,
test.
can you use parametric test in this scenario?
No.
No. Okay. Then
No,
histogram also you can see the histogram, baseline histogram. Here also you can say that there will be a something. It is not a bell shaped. In the normal QQ plot also you can say that plenty of value is away from the straight line. Have you seen it?
Yes,
Hello. Okay. In the box plot also you can say that this is median. The lower value and the upper value to a median is not equal. It is asymmetrical. Okay. Have you seen it?
yes.
Hello. Okay, like that. If you want to publish your research in any articles, if you want a publication at the time, you only bother about the statistical test, Shapiro test or Wilcoxon, KS test. If you want a main thesis, then you can do all the things. You can paste these all are the things and you can put in your main thesis. It's not an issue. Okay, then HB 1 month. It is also not a bell-shaped curve. There are plenty of things are deviating from your normal QQ plot. For example, this QQ plot, if you see, if I can judge that this is normally distributed. Somebody can judge that it is not normally distributed, isn't it? That's why there will be a subjective judgment error will occur for a visual representation of normality assumption. You got it?
Yes, sir. Yes.
That's why we need an exact p value, significant value. That is our evidence. We always go with the p value. Here also you will get the box plot. Okay, this also upper value in lower value comparing to this dark median is not symmetrical, and it should be 4 month and 4 month. You got understood now? Okay, then I will show you. So in this scenario, which test you apply? Repeated mesh ANOVA or Friedman ANOVA? Hello?
The non-parametric test, Friedman ANOVA.
Friedman ANOVA.
Sir.
Friedman ANOVA. Very good, very good. Okay, next set. Now we both this repeated mesh ANOVA, Friedman ANOVA, this is all the paired situation. Samples are same only because only the time factor is the difference. You got understood? This paired t-test and this Wilcoxon sign rank test, it is both are paired situation only. That means samples are same only over the time point period. If you have a 2 time point, that means pre-test and post-test, we can use the paired t-test or Wilcoxon sign test. More than 2 time points, that means time series design. Suppose what you do, we pre-test we will do, post-test we will do post-test 1, then post-test 2. Suppose before giving intervention we assess the knowledge level, assess the stress level. Then after intervention, we after intervention of 1 month you will assess. After intervention of 6 months you will assess. In such a scenario, more than 2 time point period is there. In that scenario, you can use a repeated mesh ANOVA and Friedman ANOVA. Okay. Then my next question, to check is there any significant difference in the average head circumstances between males and female? Can anyone send head circumstances is a continuous variable, quantitative data, yes or no? Male and female, which type of data it is? Which type of data it is?
Qualitative type of data.
Qualitative, that means nominal data. So can anyone say that which is dependent variable and which is independent variable in this situation? Head circumstances is your dependent variable, and gender, that means male and female, that is independent. Okay, you got my point. Especially in SPSS
Yes,
point of view, you can say that a factor variable, that also you can synonyms of independent variable. That not an issue. Okay, here also there are 2 options are there. This case is independent situation, unmatched situation, unpaired situation. Here only 2 groups are there, 2 independent groups are there, male and female. And here there are 2 options are there, independent paired parameter test, independent t-test. If you're plot, go to plot, the same things you have to do. Descriptive you have to put the histogram, and normalcy plot you have to pick it. The same thing. All the normalcy test remaining, these explore options are same only. Then press continue, then press OK. Then you will get a output value. Have you seen the output? Hello?
Yes.
Okay. Here you can see that here you can say that we will separately get the head circumstances, female and male. So can anyone say what is the sample size of female? 49, na?
Yeah, 49.
Male?
58, 56.
56.
56. For female, which test you have to do for assessing the normality?
Non-paired.
No.
The other one.
Because if your, once again I will tell you, if your sample size is more than 50, then only you can use a KS test. If your sample size less than 50, then you can use a Shapiro test. So female, which test you will use?
Shapiro.
Male, which
Shapiro
test
test.
you will use?
Male case.
Male, which test you will use?
Case
KS test. Very good. Here also you will get a separately head circumstances, female, head circumstances, the mean value, median, standard deviation, everything, and also the male also separately you will get a head circumference, mean mode and everything. Here you will get the test of normality result. Female, which test you have to use? Female is 49, sample size is 49. So which test you will use, KS test or Shapiro test?
Shapiro test.
Okay, female Shapiro test, which is the significant value?
0.49.
Okay, that means 0.049. That is your value, na? That value is less than 0.05. Yes or no?
Yes, sir.
That is less than 0.05 means your data is normally distributed or violated.
Violated.
Very good, very good. Then what about the male value? Male, which test you will select? Sample size is 56. So which test, Shapiro test or KS test you will check?
Case.
KS test. So you
KS
can see the 0.00. That also less than 0.05. That means here you can say that both the value is violated normality assumption. Yes or no?
Yes,
So are you able to do parametric test?
No, non-parametric test.
Okay. Here also you can say the histogram, a histogram female, histogram male. Okay. And the QQ plot female, male. Okay. Here also you will get a, what it is, box plot, female and male. Okay. Like that, many things you will get. Okay. But you don't bother about that things. Okay. In this scenario, which test you will test? Which test?
Man Whitney U test, non-parametric.
Very good, very good. Okay, next case. Suppose here it is male and female, na? Suppose I want to assess male and female and transgender. There are 3 independent groups are there. Suppose to check is there any significant difference in the average head circumstances between male, female and transgender. If such a scenario, which test will I can use? Which all are the options? In a such a scenario, you can say that not only 2 groups are there, more than 2 independent groups are there. One is male, female and transgender. In such a scenario, we can't use a independent test. Such a scenario, you can use ANOVA. Suppose my question, to check is there any significant difference in the average brain volume among various group of treatment. There are 3 groups is there. One group undergone treatment A, second group undergone treatment B, third group undergone treatment C. So then after that, I checked the brain volume. Then treatment A group population sample got the brain volume. Treatment B group also brain volume. Treatment C group also brain volume. These treatment groups are your independent data. Okay. What will be our parametric and non-parametric test? Parameter is, suppose if your data is normally distributed, then you can use ANOVA, one way ANOVA. If your data violated normality, then you can't use ANOVA. Then you can use a crystal value test. Can we do the practice? You got my point, na?
Yes.
yes, sir.
Okay, go to analyze. Same things you have to do. Go to analyze. Descriptive statistics. Explore. Then you have to reset it. What was my question? What is my test variable or outcome variable or dependent variable? Is brain volume. You have to put your brain volume into dependent variable. What is your independent variable or testing variable or factor list? Treatment groups. You have to put treatment groups in factor list. Okay. Then the same things plot you have to do. You have to type histogram and you have to type a normality plot with the test. Then press continue. Histogram, the same things which already learned. Then you have to press OK. Then first you have to check the sample size. Can anyone say what is the treatment day? How many samples are there?
35.
35.
Treatment B 35. Treatment C is 35. So which test you will use?
Shapiro.
Very good. Shapiro Wilk test you can use because the sample size is less than 50. If your sample size is less than 50, then you can use the Shapiro test. So all this group you can use a Shapiro test p value, significant value. So can anyone say that what will be your Shapiro test p value? Treatment A. What is your p value? Shapiro test p value. Treatment A.
1.47.
That means 0.147. Yes or no? Hello.
Yes, sir.
That is
Yes.
more than
Yes, sir.
0.05. Na? That means your data is
Yes.
that means your data is
Parametric test.
Parametric.
that means your data is normally distributed. Yes or no?
Yes.
Second, what about
Yes.
that is second one is 0.403.
Also,
That also
Normally
normally
distributed.
distributed. Third one is
all are
that
distributed.
also normally distributed. Then you can use a parameter test. That means indirectly we
Yes.
can say that your mean and standard deviation is a good enough to represent to compare your data. That is the normalcy. You got it. You got it.
Yes.
Understand?
Yes.
Okay. Suppose any of the treatment A, treatment B, treatment C, any of the thing is violating any of suppose treatment C, you got the significant value 0.001. So will you able to do parameter test?
No, sir.
In that
No,
scenario,
sir.
you can use a non-parameters. Here also you will get a histogram, treatment A, treatment B, treatment C. Okay, here also QQ plot, quantile plot, and this box plot, everything you will get. Okay, here you can say that the treatment B, you see the treatment B box plot, you can say that it is not a symmetry. Yes or no?
Yes. Yes.
But in a statistical test, what it is saying that it is a symmetrical. You got it now? So that's
Yes.
why sometimes for visual representation we will get an error. Okay, you understood. So in this situation, which test you are going to use? ANOVA or critical value?
ANOVA. ANOVA.
Very good, very good. Another my objectives to estimate is there any significant correlation between weight and height. Okay, I want to check is there any correlation between weight and height. Okay, weight and height both are quantitative data. So there are two options are there: Calpiation and Spearman-Rank correlation. If your data is normally distributed, then Calpiations. If it is violated, non-parametric test, Spearman test you can use. So where you have to go? Same. There is a thing is there. Have you seen maternal weight and maternal height? So what you have to do? Go to analyze. Same things. Descriptive statistics. Go to explore. Okay. Then you have to reset. Then you have to select maternal weight and also maternal height. Both in dependent variable you have to select. Both the continuous variable you have to put in dependent list. Both continuous variables. Maternal weight and maternal height. Plot you have to select histogram. Then normality plot. Press continue. Then press OK. Then first you have to check the sample size. What is your sample size?
105.
Then you can use a KS test. Yes or no?
Yes.
Okay. Then KS test significant value. Maternal weight. First you have to check the maternal weight, whether it is normally distributed or not. Maternal weight.
Normally distributed.
Because p value is more than 0.05. It is
0.5.
okay. What about maternal height?
it is not.
It is not normally distributed.
Not normally distributed.
So are you able to do parametric test?
No, non-parametric
No,
test.
sir. Non-parametric test.
Which test you will use?
Spearman.
Yes.
Spearman test.
Same.
Okay. So I will take 10 minutes more. I am extremely sorry. Okay. Anyway, now you understood what is parametric test and what is non-parametric test. Okay. You understood now?
Yes.
Yes. Yes. Sir.
So what to report? This is also very important. What to report? If your data is quantitative variable, then there is two options. If your data is normally distributed, then you can use the mean and standard deviation. You understood now? That's why all the parametric tests you can use the mean and standard deviation. If your data violated normality assumption, then you can use the median and the intraquartile range. That means Q1 and Q3. That means All your parameter tests, you can use mean and standard deviation. All your non-parameter tests, you can use median and intraquartile rates. That means Q1 and Q3. You got my point?
Yes.
Okay.
Yes, sir.
Then if your qualitative data or categorical variable, what you can use for reporting data? Frequency and percentage. Okay. Any of the qualitative data, whether it is nominal or ordinal, you can use the frequency and percentage. You got it now?
Yes, sir.
Okay. In hypothesis test, there is a parameter test. Especially parameter test is normally distributed data, na? Huh?
Yes.
So
Yes, sir.
Yes, sir.
usually
Yes,
we
sir.
compare by using mean. Especially here we are using mean. Okay. Non-parameter test is violating normality assumption. Na? So what we usually compare? Medians. You got my point now?
Yes, sir.
Yes, sir.
So in hypothesis testing, parameter test, suppose in a paired situation, you have over the 2 time period, at the time you can use either paired t-test or Wilcoxon-Sign rank test. If you have more than 2 time points, pre-test, post-test, post-test 1, post-test 2, in such a scenario, you can 2 test repeated mesh ANOVA and Friedman ANOVA. If you have 2 independent groups, not in a paired situation, unpaired situation, unmatched situation, at the time you can use the independent t-test and Mann-Whitney U-test. If you have more than 2 independent groups, male, female, and transgender, otherwise treatment A, treatment B, treatment 3. So in such a scenario, ANOVA and Kruskal value. Suppose if you want to find out the relations between 2 quantitative variables, so you can use the Kalp-Pearson's correlation or Spearman rank correlation. Now you understood about what is the importance of normalcy. You have to ask yourself that, because we already did our research in degree time or PG time or PhD time, whether we checked our data is normally distributed or not, whether we guide our students and we encourage and we force our students to do normality assumption or not. Okay. So you have to ask yourself. So in today's class, you understood the importance of what it is, normality. You got my point now?
Yes, sir.
Yes,
It
sir.
is a very important. The importance of doing normality is a very important.
Sir, whether you can arrange some other classes dealing with this parametric and non-parametric test.
Definitely. That we will announce later, because today itself there will be a 7 days entire SPSS section will be available. In there we will go through all the things.
Okay.
If anyone is going to interested, our ma'am will announce it later. Okay, then what I mean is that then I will conclude my section. So what we learned, normalcy. How to check normality? There are visual method is there, statistical method. Visual method, histogram. You have to check your histogram whether it is normally distributed or not. Then there is a box plot. You have to check whether median towards upper side and lower side is symmetry or not. Then there is a quantile plot. Then you have to check whether your all value is equal or nearly equal to your straight line. Then also there is an statistical method. There is a 2 types of Kolmorov-Smirnov test, that is KS test if your sample size is more than 50, or Shapiro-Wilk test if your sample size is less than 50, or decision, or if you and what will be your null hypothesis? Null hypothesis saying that your data is normally distributed. Okay, and decision if p value is greater than 0.05, data fulfills normality assumption. If less than 0.05, that means your data violated normality assumption. If your data fulfill normality assumption, then only you can use a parametric test. Then only the mean and standard deviation is the good representative of your data. In other ways, you can use a non-parametric test. So here you can use a median and intraquartile range. You got my point now? How to report your data in your statistics? You can say that Shapiro-Wilk test indicated that the data is normally distributed. Then you can write the p-value. P-value, you got the p-value now, the SPSS significant value. You bracket, you can write the p-value. Like that, you can report this data. Do you have any doubt? So this is end of today's section. So thank you all of you for your kind cooperation. So do you have any other doubt? You can ask me. Hello? Do you have any doubt?
Sir, this is Kannan.
Hello? Ah, yes.
Can you hear me?
Ah, yes, I can.
So how to interpret this table with assumption, because this is a normality. After the normality, for example, paired t-test, we have done that with the paired t-test, the table value will come. That how to interpretation, and with the assumption, how to do that. You are giving that one example, that is fine.
For only paired t-test.
Yeah, and just I'm asking for that example. Only paired t-test.
I will tell you. In paired t-test,
yes.
you can write like that. For example.
For the table form,
I will tell you. Table, you don't write anything else. In normalcy test, you don't put any table. No, there is no necessary to put any table. Suppose here, can you see my output window?
Yes.
Here you can see that a KS test, that means Kolmorov-Smirnov test, indicated that this maternal weight is normally distributed in the population. Then bracket, you have to write P is equal to 0.200. Okay.
Yeah.
Then you can write in case of maternal height, this data is maternal height. The data is not normally distributed. P is less than 0.01. You got my point?
Yes.
Hence, we can't use parameter test. Hence, we use a non-parameter test.
Okay.
So you have to justify why you are using Spearman rank correlation. You have to justify it. This is the justification.
Okay.
You got my point, sir?
Yes.
Oh, like that you can put only the p-value. You can put it bracket.
Okay.
That's about the.
What about the standard deviation and mean value?
Standard deviation, mean value, nothing. That will come when you parameter. That is a You are asking about a paired t-test reporting.
Yes.
Because anyway, I will show that thing, because that is not in our syllabus. But I will show you. 1 minute. 1 minute.
Okay, no problem.
No, that is not in our syllabus, but that will be our entirely, definitely that will be there in our next section. I will tell you there are plenty of things are there. Once again, where that is. Can you able to see my window?
Yes. In that interpretation, I can see that.
Suppose if it a paired t-test, then you can write the descriptive statistics mean and standard deviation. Then you will get a t statistics. Then the significant value you have to put. Then you have to write paired t-test indicated that there is a significant difference in the average SPP measured at 2 time points. Then you have to write back at t value and p value. So that
you
is
ask your,
you didn't.
Okay, sir. Thank you.
Okay. Any others have any other doubt? Hello. Hello.
No, sir.
It's clear.
No, sir. Yes, sir. Yes.
I will hand over the section to Mr. Disha.
Thank you, sir. Thank you so much for such a knowledgeable, stimulating, and an interesting session. We are really grateful and we appreciate you, sir, for giving us your time and efforts as you cleared out all our concepts on the topic of normality. Thank you so much, sir. And we give this opportunity to the participants. If anyone wants to share their feedback or just any experience, if all the participants who are listening to me right now, if you want to share, you can please take 2 minutes and please share your experience regarding this webinar.
Hello, this is Kannan from Bangalore.
Yes.
This session was good, but already I have shared my feedback. The content study materials with the PPT can be shared. That is one concern from my side. Others participants also will be benefited. It's not only me, because we are paying and attending the workshop. If we are getting the materials with objectives, with the output, with the demo, that is for the useful. Okay. So for that is my feedback. Otherwise, it's okay, fine.
Sir, definitely. Hello, sir.
Yes.
Hello, sir. Definitely, I will send one article that will be very beneficial. Okay.
Okay, no problem. No issues.
That will be very beneficial.
Okay.
Thank you, sir. Thank you for your feedback. We'll definitely look through it. What can be done? We'll definitely make sure that we fulfill your things that you say. Anyone else? If anyone wants to say something, then we would really appreciate your kind words. Okay, then, thank you so much. Here we come to the end of today's webinar. Before we move ahead and I tell you about the future coming prospects, it's just a general information that soon after this webinar, a feedback link will be sent to your respective email IDs. Please go through that feedback link and definitely fill up your feedback forms. And I request all the participants and all the beneficiaries here to please put the correct spellings of your name, as the same will be used for the certificates that are going to be provided to you. I hope this session was fruitful and beneficial to everyone here. So now here are the future prospects and future projects of our Brio International Nurturing Academy. There's soon going to be an online course for all the healthcare professionals, be it medical, nursing, paramedical, for all the faculties as well as the students regarding data analysis using Spss software. It is going to be a total overall 18 hours course. Actually, the actual course fees of this course is 9,000 rupees, but since all of you have attended this webinar, so we are going to provide a 50% discount. So you can pay rupees 4,500 Indian rupees, and you can definitely get a benefit from this online course. After this, we are going, and one more thing, if you attend this webinar, you are also going to get benefited. As you can see, the syllabus is written like right here on the left-hand side, and I think so it is clearly visible on your screen, so you can see what all will be the benefits and key points which you will learn through this online course. So I highly recommend also and encourage everyone to please get enrolled in this. Next slide, please. Not only this, we are soon going to have another webinar that is going to be held on 27th of June. The topic of the webinar is systematic review. That is, the systematic review process is going to be our next topic for the webinar. And our resource person is eminent Dr. G. Balamurgan, who is himself a PhD holder, an MBA registrar and HOD of mental health nursing from Ramya Institute of Nursing, Education and Research, and as well as he is also a joint secretary for Indian Society of Psychiatric Nurses, that is ISPN of India. So I am really hopeful that this webinar is surely going to be a wonderful one where we are going to learn a lot about systematic review process from such excellencies. So you can also register for this. The registration fees is right here. It is written rupees 400. And the email ID is also given where you can contact us for any further queries and doubts. So at last, we come to the end of the session. Here I put the curtain to this entire webinar. Again, thank you so much for being such a wonderful audience, and I hope you were really benefited. So Brio International Nurturing Academy, at the end, thank everyone for your participation and for being patient listeners. Thank you so much.